Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see the implementation of DFS in this session. As we have discussed about DFS in the previous video, you can look into that video for a clear understanding of this implementation of DFS. At the end, I will be showing you the execution also. Once you can refer that video for execution purpose. And let us see, this is the code where you are going to write it for implementing the DFS. Now, in the similar fashion, how we have done, we need to include the header file and the size of your stack. Here we are going to use the stack data structure instead of queue. Here we are going to use stack. And there we have used front end array. Here we are going to use, for the stack, we are going to use the top is initialized with -1. These things, as we have discussed, stack is an array data structure where you are going to store the values which you are going to, that is the vertices which you are going to visit, and the size depends on the number of vertices which you have. And the visited array represents whether you have visited a particular vertex or not. If it is initially, it will be 0. After visiting, you are going to represent with 1. Okay, and this is the push function where you are going to insert or push an vertex onto the top of the stack. And this one will be checking if your stack is empty, that is top equal to -1, it returns 1. If stack is not empty, it returns 0. These are the two cases. And before going to see about this is a thing where we have discussed in our BFS also. First, we are going to give the number of vertices. You can refer that video also. There I have given a brief description about the number of vertices and how we are going to read the adjacency matrix, and we are making the visited vertex as initially we are going to make visited vertex as a 0, and we are going to take the starting vertex as 1. For all this, you can refer the implementation of BFS video. Now see, here we are going to see the main DFS logic, how it is going to work. Initially, we are going to take a stack. This is the stack, right? Top equal to -1. The size is the same graph I am going to take. This is the graph which I am going to have 1, 2 and 3. And the matrix where you have is 1, 2, 3, 1, 2, 3, 0, 1, 1, 1, 0, 1, 1, 1, 0. This is the matrix. Based on the edges, I have represented it. That's why, once again, I am telling you, you once check this, how adjacency matrix has been written, all these things, you can refer the implementation of BFS. That video was there. You once check that video. Now, this is the matrix and this is a stack where we are going to have. Initially, flag value is 0. One condition I will be explaining, the remaining cases will be the same. Okay. Initially, flag is 0. Okay. Now, we are going to push the first vertex, the starting vertex, I am going to take it as 1, so that 1 will be pushed onto the stack. In the stack, that is in the insertion or push function, we are going to increment the top value. Top will be incremented. This is from 0, 1, 2 and 3. Top will be incremented so that we are going to push that 1 onto the stack. Now, top is pointing to 1. Now, visited of 1. Visited of 1 means we are going to have the visited also, we have taken one array, right? 1, 2, 3. Visited of 1. Initially, it will be of 0. Initially, by at the time of main function, we have represented all the visited vertices or initialized to 0. That's why initially all the values are filled with 0. Now, visited of 1. Visited of 1 is nothing but we are pushing the first vertex so that it becomes 1. Now, you need to print the value of this. We are going to print the value as 1. Right. Now, we are going to check not is empty of. That means the stack is not empty. You are having one value into the stack. Initially, flag value we are initialized to 0. Yes. Now, x equal to stack of top. Into x, I am storing the value of top. Top value is nothing but 1 value. Now, we are going to iterate the loop. How we are iterating? A of the first iteration I am telling, in the same way the remaining cases will be. X is 1, I is also 1, equal to 1, and visited of 1 equal to 0. What is A of 1 value? Is 0. 0 equal to 1, condition fails. Visited of 1 value equal to 0. Visited of 1 is also 1. 1 equal to 0. Here also the condition fails. It will not enter into this block. The first case. In the second case, I becomes 2. 2 less than or equal to 3. Condition true again. A of X is 1 only, but I becomes 2. And visited of 2 equal to 0. Now A of 1, 2 is 1. Is 1 equal to 1, condition true, and visited of 2 is nothing but 0 equal to 0, condition true again. Both the conditions are satisfying. So now what we are going to do? We are going to push I onto the stack. Push of I is nothing but I value is 2. That will be pushed onto the stack. Now top will be incremented here. Top is this. Now print the I value. I value is 2 will be printed. Now visited of I. Now visited of I is nothing but visited of 2 becomes 1, right. Now we are going to make flag value equal to 1. Now initially it was 0, now we are making this as 1, right, and we are going to terminate this loop. This loop will be terminated. This for loop is going to be terminated, and it will be checking flag equal to 0. No, it is not 0, right. Now, if it is 0, then we are going to decrement the top value, but it is not 0. Now, again, it is going to check for is empty. The stack is empty? No. Again, we are going to initialize flag value to 0. X equal to stack of top. That means now X becomes 2. Again, it is going to check the same conditions. All these conditions will be verified, and it is going to push the value onto the top of the stack. 3 also is going to be pushed onto the top of the stack. And you don't find anything here. You don't find any elements left over, not visited vertices in this. Now it is going to check is not stack empty. No, stack is not empty. Stack is not empty. Now it is going to make our flag value equal to 0. Now after this, the 3 is also going to be removed from the stack. Now it is going to check flag equal to 0, right. At that particular case, what happens? Flag becomes break. X equal to top 2. Next time it will be of 3. After this, not of stack empty, right. Now at some case it becomes flag equal to 0. Now it is going to check is not stack empty, flag equal to 0, top should be decremented. Now top is going to be decremented, and you are going to remove the element 3 from the stack. And after that, again it is going to check is not of stack empty. Again you have 2 value here. Still we didn't remove anywhere. The elements which was there in the queue, that was not removed, right. Just we are placing the values. We are going to remove it from the stack. So top will be decremented, top will be here. And at the next case, top will be decremented and top will be here. Now your stack becomes empty. In this case, we are going to say that your DFS is going to visit all the vertices in the graph. Okay, this is how you are going to work with your DFS. Let us see the implementation of this in online C compiler once, so that you could understand how this is working. My projects, yes, DFS, whatever the code we have discussed, the same thing I am executing here. Once you can run the same program. Number of vertices same 3. Adjacency matrix, I am taking the same adjacency matrix. For this, you will be getting the same result. I have taken only 3 vertices, that is why. 1, 1, 0. Right. You will be able to see the same result as of a BFS, but you can check with the different graphs also. It is going to work. Okay. This is how you can implement your DFS. Still, while tracing your program, if you have any doubts, please comment in the comment section so that I can clarify it. Okay, I hope you understand this DFS concept implementation. Thank you.